Question 11. The equation that links gravitational potential energy, mass and height together is Gp equals mgh. Part 2, you need to substitute in this equation. Actually, it's a bit of a cheat, isn't it? Because the real equation is that the change in the gravitational potential energy is equal to mg delta h. If we're working out the potential energy gained, then that's where the delta comes in. That's the increase in potential energy. Mass is 200. G is 10. You should remember that. But if you can't remember that, it's on the inside cover of the exam paper. And then the change in height is 128 meters. Stick all of that into a calculator, and you get 2.56. Well, you actually get 2560000 joules, which, if you take it, is approximately what they told us, 2.6 megajoules. For part B, the clues in the question. The command term there is state, which means that you should just be able to write it down without any further calculation on your part. So the minimum kinetic energy that the car must have, if it's going to have enough energy to get over the rise, and it's got 2.6 megajoules of gravitational potential energy, then the kinetic energy that it must have as an absolute minimum is the same, 2.6 megajoules. Part 2, how is the kinetic energy gained related to the work done? Again, that's quite straightforward. The work done is equal to the kinetic energy, which means that you've got to do work on the car to accelerate it, to give it more kinetic energy, and those, because of the principle of conservation of energy, those two values are going to be equal to each other. Equation linking work done with force and distance, very straightforward. And then they're giving us the force and they're asking us to calculate a minimum length, so they're asking us for the distance. So if you rearrange that equation, you'll get D equals the work done divided by the force, and then it's a simple matter of substituting. Our exact value that we'd worked out was this, and then the only trick there is that it's a kilonewtons, so that's 32,000 newtons. Plug all of that into a calculator and we get 80 meters. In part C, it talks about two different situations. It talks about when the track, when it's windy, or when the track gets wet. So ideally we need to take each of those and give an explanation for each one of those to get those 2 marks. So let's start off with when it's windy first. So when it's windy, there's increased air resistance on the car, so some of its kinetic energy is going to be wasted to heat via the process of friction. So those were the points for if it's windy. Whoops. And if it's wet, then there's going to be less, because it's wet, it'll be slippy, so there's less friction between the launching system and the car itself. So that means that there's going to be less energy transferred to the car, because some of the energy will have been wasted. And that is the end of the paper. Hooray!